All right. Hello, everyone. My name is Basarat. This is a talk about TypeScript. How many people here are familiar with TypeScript? Can you raise your hands? Excellent. There are a few that aren't familiar. This is an intermediate level talk, so I will try to get the beginners on board as much as possible. One thing to note about TypeScript is that it is all about just JavaScript. It is essentially the JavaScript that runs in the browsers today, plus upcoming JavaScript standards, followed by additional syntax specifically for type annotations. It is by Microsoft, but it's the new and open source Microsoft. They're really doing some pretty excellent stuff. And the real objective of the TypeScript team has always been just to help you write better JavaScript. It starts and ends with JavaScript. So let me just jump into the demos. So here I have a JavaScript file. If I can stop the slides. Cool. Anybody see any issues in this simple piece of JavaScript code? Like very drastic, definitely wrong, it's going to give a type error issues. That's pretty much the experience with most JavaScript code out there. You just assume that it's going to function. And that's where TypeScript is designed to help you reason better about JavaScript. So if I just paste in that exact same JavaScript code into a TypeScript file, TypeScript has actually found a number of issues in this code base, even without any special TypeScript-specific syntax. One of them is over here. You want to take a guess at what's wrong? Parse int takes a string, and someone's passing in an HTML element. I don't know, I can just go something like this or whatever, get some text from the DOM, and then pass input function, not be a type error. There's an error in this line as well that TypeScript has identified. Anybody know what that is? So delivery method is a function that returns a string, and someone's doing this. Now it's a very subtle thing, and it's easy to miss in code reviews. And that's, again, something that TypeScript can automatically capture for you. What was happening there was only one pipe instead of two pipes, and that's the bitwise OR and not the OR, which is the standard way that JavaScript devs provide default values. So that error is fixed. Now have a look at this send updates function. There's a comment here, an email address or an array of email addresses to ship to. Like that's something that's really well represented as type definition. And now the user doesn't actually have to necessarily read the comment. You can actually just hover over it, you get autocomplete, and it's actually finding a bug over here as well. The person who wrote this code was probably a beginner. They were like, if email address.length. Basically what they were trying to do is, if it's an array, then send an email for each element in the array. Otherwise, just call it with the first value. And .length is something that exists on a string as well as an array. So this discriminator is actually not valid. The proper way to discriminate, one of the ways at least, is to use array.isArray. So we had an email address which can be a string or an array of strings. As soon as you use that, TypeScript has actually figured out that within this if condition, email address is going to be an array. Within the else, email address is going to be a string. So TypeScript understands a lot about the JavaScript runtime that's by default present in browsers and JavaScript environments. And this is like, I just went into the definition of is array. Like this is all the stuff that you'd have to keep in your head. I can keep scrolling for hours. It's not gonna. But TypeScript can provide you autocomplete and IntelliSense and fix very simple issues that you might miss in your code base just by using standard JavaScript. There's an error over here as well. Anybody want to take a guess what they did wrong over here? They have the values so for each email address, send an email, they have the index as the first and value as the second. Well, actually, in JavaScript, for each returns, the callback gets the value as the first argument and index as the second. We're not using the index, so I can actually just delete that, and that error is gone as well. So just a JavaScript file, put it into a TS file, it finds issues for you. So that's pretty much an introduction to TypeScript. So the TypeScript team has actually been pretty busy. There are lots and lots of features, and some of these features aren't even covered in the changelog, because what they do is they just understand more of your JavaScript and find more patterns that are causing bugs and fix them for you without beating a drum about it, and they're doing an excellent job. One of the features that came out in the last year was allow.js. So this has been a point of contention between people that want to use TypeScript and don't want to use TypeScript, that I just want to have a JS file, I don't want to have a TypeScript file with the additional TypeScript syntax. Well, you can migrate your JavaScript project to a TypeScript project simply by adding the allow.js compiler flag to your TypeScript config options. And as soon as you do that, TypeScript can understand JS files, and it can actually transpile them to whatever target you might specify. For example, over here I've specified that I want it transpiled to ES5. So this ES6 arrow is going to get transpiled into just an ES5 function, hello world NDC, and you can see that TypeScript is doing that on the 5. Similarly, const and let, you can transpile them away as well if you're targeting ES5 and whatever. So you can actually use TypeScript on a pure JavaScript project by just writing JavaScript, and you can use it as just a transpiler without any type checking. But they've gone a step further. Now, with allow.js, they always had syntax errors are syntax errors. However, type errors were not checked, because your existing JavaScript code base might be too massive. You have external dependencies, like this external dependency is changing the bar member of foo to be, looks like a string, maybe because it's got the trim method magically, which is not something that exists on a number. They've added this option, check.js. So with just allow.js, you don't have to worry about immediately migrating all your JS to type safety. It would have just worked. But now they've added an option, check.js, which means that you can actually continue to use just .js files, and TypeScript can type check them for you as well. For example, over here it's starting to complain that cannot find this external thing. Trim is not something that exists on a number. So now we understand that moving your JS to TS immediately might be a lot of work for you. So another feature that they've added in the last year is quick fixes. And one of those quick fixes is disable type checking for this file. So with check.js, there's a comment now on the first line, TS no check, which means that this file is not type checked anymore, and those errors go away. You can Yes. So the question is, couldn't you have done this with just an any annotation? You cannot have annotations in a JS file. So allow.js, you have a JS file with JS syntax, so you're not allowed to use any extra syntax. For example, bar is of type any. That's a syntax error. It's not JS, it's TypeScript, it's in a JS file. So because you cannot have type annotations in a JS file, you have to explicitly buy into check.js, and then you can ignore individual errors, like I've just done for this external dependency, or as I did previously for the whole file. So that is check.js. Now this is one of the best features, in my opinion, that have come out in the latest version of TypeScript, which is AsyncAwait. Like I said, it's a new Microsoft. They're really all about the open source, and they really want to help JavaScript developers. And AsyncAwait is something that's made into the ES spec because of efforts of people within Microsoft. It is from C#. So for a language that is purely about async programming, which is what JavaScript is, single thread, can do 100 things in parallel, it's fairly painful to do async programming. So if I have a function that, I don't know, wants to do some work after 1 second, then 2 seconds, then 3 seconds, I would write it as, well, set timeout, do some work, just log out 1 second for now, and do it in 1 second. And then I want to do some more work after 2 seconds and after 3 seconds, and this is where it gets a bit funky. Do some more work after 2 seconds, then do some more work after 3 seconds. And you can see that it does work, but it gets fairly painful. And when you throw in error checking and all those other requirements that we have with real world code, callbacks aren't particularly ideally suited for that. So people have come up with a better pattern for this in ES5 as well. So what you can actually do is create a delay function that takes some milliseconds, returns a new promise, oops. And like, I don't need to actually use any type annotations if I don't want to in TypeScript. I'm not annotating millisecond is a number. I'm not annotating that promise is going to return a promise of void in this case. So all I'm simply going to do is promise constructor gets passed in the resolve. So I'm going to call resolve after the specified milliseconds. And now what you can do is, instead of all this funky callbacks, you can just do delay for 1 second, then go ahead and log out 1 second, then delay for 1 more second, and repeat. So 2 seconds and then 3 seconds. Of course, I forgot to, don't you love TypeScript? It pointed that error out for me. Didn't need help from the crowd. It's supposed to pass in a function. I'm passing in a void to thens. So that's fixed. And of course, it does work. But then it's still a lot of functions that you have to write. And then you have to think about, OK, so code that's going to execute over here is going to execute before this gets called, and stuff like that. So the TypeScript team brought into ES and as well as in TypeScript async functions. So now what you can simply do is await anything that returns a promise. And now the code that's going to be present over here is not going to execute till this delay, the promise returned by delay resolves. So now I can actually simply do log out 1 second, 2 seconds, and 3 seconds. And TypeScript can transpile it down to ES5, and you can run it wherever. So that's actually one of the best features that have come out in the last year. Any questions about that? Yes, yes.
If you go back to your previous example there, you put a loop around that, and it's
Very, yes, exactly. So a lot of the patterns that you have in asynchronous programming, they just work naturally with asynchronous programming with AsyncAwait as well. OK, so generators. Well, generators is another one of those features that's really, really cool. It allows very powerful patterns, for example. So IEnumerable and yields for people in C# that have used that. It's the same thing, not same, but similar. So what you can actually do with generators is, for example, generate an infinite list, for example, a list of whole numbers. So I can go ahead and create a function that is going to yield one by one a value from the whole number set. And there's no TypeScript specific magic over here, but TypeScript's already figured out what this thing is going to be. It's going to be something that returns an iterable iterator of numbers. So I can actually use it with a for-off loop, get me all the whole numbers one by one. So this is lazy iteration. If I wanted to iterate all the whole numbers without this, I'd have to keep state and a lot of other funky stuff that I simply don't have to deal with anymore because of generators. So I can loop through the results of whole one by one, and let's just terminate at something like that. Then just break the for loop. Otherwise, simply just log out the item, and no surprises, no prizes for guessing. It's going to be the items that are being lazily returned by the whole number function. There are a lot of programming patterns that become much easier with generators. For example, I have a linked list over here for people that know data structures. Linked list is just each item has a pointer to the next and a value. Each node has a value. So that's a linked list node. And here I have a linked list that you can push stuff into. I want to loop through all of the values in the linked list, knowing that someone might be iterating through the linked list items in parallel. The iterator that I have to return from a potential values function lazily would be, well, complex. But with iterators, it's actually quite easy. So I start with that, I don't know, current is equal to this dot head, while we still have a current value. I can simply go ahead and yield the current dot value, and then for the next iteration, I would simply move this to the current dot next. And now I can actually go ahead and again use for off to lazily iterate all the items from this list dot values. Just log out item. So if I demo this file, I expect to see 1, 2, 3, 4. One more trick with iteratables: if you actually want to make them an array, you can just use array.from, and it'll run through the iteration and collect the results into an array and give that back to you. So this should be an array of 1, 2, 3, 4, and that works as expected. So very complex patterns are now fairly simple thanks to generators, and TypeScript understands them and can transpile them to ES5. Any questions about that? Great. Let's jump to the next one. Spread is another thing that's actually I use quite a lot. TypeScript can transpile that and understand that. For example, if I have an object that has A, I don't know, some number, B, some number, and then I have another object that has some number C. Now, if I wanted to merge these two objects into a third object, I could loop through the keys, create a new object, loop through the keys, and put each key value into the new object and return that. But now I can even use an object spread and create a new object simply by spread all the stuff from foo and spread all the stuff from bar. This is spread. Now, the great thing about using TypeScript for this is that it actually understands what's going on over here as well. So it's figured out that Baz is something that has all the members of foo as well as all the members of bar in there. So baz.abc, it's all in there. You can also take out values from an object with a REST destructuring. So you could always do something like, not always, but for a while you've been able to do something like this. Take out C from this object Baz. And again, since it's TypeScript, there are absolutely no annotations on the file right now, but it's figured out that C is something that is of type number, because this was of type number. You can move everything else other than C into whatever you want to call it. And again, TypeScript is going to figure out that, okay, so you've taken C out into this destructured variable, and everything else other than C has gone into this variable over here. Something like this is great with React and spreads, and when you get one props and you want to pass a different set of props to your child components, stuff like that. TypeScript understands that. Don't need any annotation, just works. Any questions about that? Cool. The next one is literal types. So TypeScript now also has literal types. It's fairly simple. So you've always been able to do foo is something that is of type string. It can accept anything within the string domain. But now TypeScript even has literal types, so you can actually say that just the literal string hello is allowed for foo. And now if you try to assign some other string to foo, that's an error. The only string that can be allowed is the exact string hello. And you'll actually see that TypeScript does autocomplete as well, because it knows that these are all the allowed values. So really fancy stuff. Kudos to the TypeScript team. So that's fine, but you would normally, like, if you just have one value, it wouldn't be particularly useful. Well, TypeScript has had union types for a while. And I can have literals with unions as well. So for example, let bool is something, it's a variable that can accept two values, true or false. So bool is equal to true is allowed, bool is equal to false is allowed, bool is equal to anything else is an error. I can even, so normally you wouldn't annotate bool like this. There's a special type for that anyways, Boolean. But you can even do stuff like, okay, so sometimes it's really great for mapping server responses and existing APIs out there. Some APIs have something like it is valid or invalid with this reason. So you can actually map that in as well, that payment failed is one of the valid values. So this is really something that can have true, false, or payment failed. Anything else is not in the union and therefore cannot be assigned. So TypeScript has had unions for a while, but now it's got literals as well, so much more powerful. What's great about when you combine unions and literals is you actually get discriminated unions as well. So for those that are familiar, discriminated union is basically a union that you can discriminate over, basically identify which member this particular item belongs to. For example, over here I have a type square that has a kind of a literal square, and a type rectangle that has a kind of a literal rectangle. I can go ahead and create a new type, which is a union of these two types. So at this point over here, S can actually be a square or a rectangle. So if I wanted to, for example, for the ADI, if I wanted to return something like, I know it's a square, so I'm just going to return s.size star s.size. Nope. TypeScript knows that, well, you said that it can be a shape, so it might actually be a rectangle or a square, so you can't do something like that. But when you have a literal type annotation for a particular member, TypeScript understands how to discriminate over that. So I can actually go if s.kind is equal to the literal string square, then go ahead and return the area for a square. And as soon as I do that, TypeScript knows over here that it can be a square or a rectangle, and over here it knows that it can only be a square, because if the kind was not square, then I wouldn't be within this if block. That's pretty cool. It has also, by the process of elimination, figured out that over here, S can only be a rectangle. So the width, star height, whatever. I'll have autocomplete. Any questions about that?
So if you change rectangle to rect, square, actually we've got square written there. So if you change it in the literal string actually in the interface, that's going to fail then. So the one above the square?
Yes, yes. So if I actually change it to something else, so it knows that there's no way that kind can be something that is not in the discriminated union, which is kind must be ASTF, FAST, or rectangle. So you actually can, and structures like this is what is actually used by Redux actions, and TypeScript can figure out which actions are available and stuff like that with these type of notations. You can even do exhaustive checks. For example, I can go ahead and create a new one. Let me just undo that. Interface, I don't know, circle is something that has kind circle, and it will have radius number. So right now, if I go ahead and add this new type to the discriminated union, there's no error. Actually, there is. It's already figured out that if the kind isn't squared, well, then S can actually be a rectangle or a circle still, so this is invalid. But even without that, if I had an explicit case over here, if S.kind is equal to rectangle, then do that. Cool? Now, since I have that explicit check over there, and I add a new item to the discriminated union, there's no error. So if you want to cater for some feature type being added to the discriminated union, you can actually add another block here and ensure that this block never executes. So there's this new type called never. I'll just call it nev of type never is equal to S. And right now, shape can either be a square or a rectangle. If it's a square, go here. Else, if it's a rectangle, go here. Otherwise, go here. TypeScript's already figured out that there is no way that this thing can execute, because there are only two types that S can be. So it's inferred that S is of type never within this particular block, and only a never can be assigned to a never. So now if the new developer comes in and they add a new type to the discriminated union, they'll actually have to handle all the else cases as well. This is called an exhaustive check for people in discriminated unions in various programming languages. So TypeScript has that as well. All right. So no implicit any is a feature that has been in TypeScript for quite a while. For example, I can have a function foo that takes a variable bar, and I just that is interesting. I just know that bar is something that has a property baz, and it has a member trim. And you can write this JavaScript code perfectly fine, but there's no real help for the next guy to realize that, okay, bar is an object that has a property baz that is most likely a string, but it may not be a string. It might be anything that has a trim function. And again, TypeScript cannot figure that out either. What is the type of trim? Is it necessarily a function? Is that, what does it return? And So there's not enough hints within this piece of JavaScript code to figure out all the types for the variables that are involved. TypeScript has added this flag called no implicit any. And as soon as you do that, anytime TypeScript cannot infer the type of a variable, it will actually mark it as an error. And if you still want to be a cowboy, you can still do, and I love that word, cowboy. Or you can actually be a better person and write in that it has something that is whatever. Cool? So no implicit any. That's been there for a while. But now they've added a lot of other similar flags that help catch bugs early at compile time instead of runtime. Arguably, this in JavaScript is one of the most misunderstood and abused things. The reason is that it gets disconnected from, people assume that when I have a function, this is bound to a particular value. That is not generally the case. It is derived by how you call that function. So here I have a function inc. This just goes ahead and adds something to the count on this. So I can actually go ahead and create an object foo that actually has a count. And I can add the increment function to this as well. And now if I actually go ahead and log out foo.count before I call this function and call this function and log it out after. Now since I'm calling this function increment on foo, this is going to point to foo, and the count of foo is going to get incremented. If I just run this file, you can see that it works as expected. It was 0 and now it's 1. But if I go ahead and disconnect this function, or rather pass this function to either set timeout or someone else to call at a later point, or as an event handler, what can happen is like foo increment is the increment function. Here's something, call this function for me later. That thing calls it, and everybody dies. The reason is now this function, the increment function, is being called without the correct context. TypeScript can actually figure that out as well now. There's a flag called no implicit this, no more magical this. Anytime you have magical this, it becomes an error. Over here I can actually say that, okay, so this must be something that has a member count on it. Cool? So that's fine, but now you're calling this, TypeScript has figured out that you're calling this function on something that doesn't have the member count on it, and it's map that to an error. So you'll actually have to do foo.increment. TypeScripting has been very busy. They've added a lot of features that capture bugs early. Another one is no unused parameters. So imagine you have this function that has argument and a massive body, and this code was written 10 years ago, and not 10 years ago, but maybe 5 years ago. Actually 10 years would be fine as well. JavaScript's been around longer than that. And well, this parameter is no longer used, and the new guy comes in, he's like, I'm not sure if this is relevant or not in any way. Well, TypeScript can figure that out for you. There's a flag called no unused parameters true. And now unused parameters like this become an error. So you don't have to worry about it. Another similar flag, no unused locals. You have a massive function over here. It has this variable created for funsies, is what we call it in our team. Well, you can just switch on another flag, no unused locals, true, and that bad boy sticks out like a sore thumb.
So I actually have a question. You discussed global, and then inside the function scope they actually do the var that equal to this thing. What do you think about that? Is that a good thing or?
That's perfectly fine. So the question is, I have a function that goes ahead and
Basically passing scopes around the way.
Yep. This dot x is equal to 1 to 3 and const self is equal to this, and this dot increment is a function that will go ahead and use self dot x. This is perfectly fine. TypeScript is happy with it if you want to do that. TypeScript will actually figure out what the variable is generally as well, so you don't have to actually worry about it. In the modern JavaScript, you'd actually normally use just an arrow, so it will actually capture this from the outside automatically. So that's no unused locals. There are a lot of other flags like that as well, and what you can actually magically do, let me just show you one more flag. So this is one of the, I'll just close all other tabs, so it's getting a bit crowded. So here I have a function that adds days of a given number to a date. Someone can actually go ahead and call this function with null values, and then everybody dies. Kittens die. And what's going to happen is that date is going to be null, and getTime is not a function that exists on null. And null handling is just a nightmare. It's not something that, if you can offload it to the language, go for it. And with TypeScript, you can actually do that. There's a compiler flag called strict null checks. The reason why it's new as a flag is because it's new. You don't have to immediately fix all your code with nulls, just the new code. You can actually just say strict null checks, and now nulls are not in the domain of the primitive types or objects or classes and stuff like that. So you cannot pass in null into date. You don't have to litter your code with stuff like if date is equal to null, then do something clever anymore, because that's someone else's problem now. As a library author, it can actually like save execution time because you don't have to do null checks needlessly. It's one of the, like, generally when you add type safety to a language, you have more runtime overhead, but in this case it's actually, it's going to save you runtime overhead because you don't have to do these checks. They can be done by the compiler at compile time.
You can annotate to say that that's the nullable date.
Yes, yes. So what you can actually say that if it is a valid case that you might accept a null, you can add a null as a union, again the literal null. And now TypeScript knows that, well, this object might actually be a null, and then you actually have to handle if date is not equal to null, then do this. And now TypeScript is actually going to go ahead and infer that this thing can actually return a date or an undefined, because the else block returns an undefined. So strict null checks, really powerful. It's like moving the maybe type into the language instead of having a special type for it. So that's strict null checks. One of the, like, instead of having to go through all these options and check them, what you can actually even do is there's an option called strict, and you set that to true, and it knows that all of these strict features, as well as any new features that might come in, to true. You can toggle individual ones off, like, well, I have a lot of, for example, let's just say no unused locals. I can go ahead and switch them off after setting strict true. Generics is really cool. It's been in the language for quite a while. The main objective of generics is to put constraint between different variables, functions, methods. Over here, I have a stack of type T, and the constraint that I want to enforce over here is that whatever you push into the stack is what gets popped out of the stack. So if I go ahead and create a stack of numbers, then I call it stack, so let's just use that. If I push in a number, that's what I get out. I get out a number. I cannot push in a string because I've said that stack, this particular stack is a stack of numbers. So generics have been there for a while. They're really cool, and they'll get used in a bit in some of the newer features that have come out. Yep?
Can you constrain the type?
Yes. So what you can actually, so the question is, can you constrain the type? What he's basically saying is that, can I say that T must be something that has a member foo of type string on it? So I can actually specify that constraint as T extends that particular type. So now I can only create a stack of something that has, like number would be invalid because numbers do not have a property foo called string. But I can create a stack of something that has foo of string and bar of, I don't know, number. Cool. So generics have been in TypeScript, and constraints, generic constraints have been in TypeScript for a while. They'll get used in a bit. Another thing that has been in TypeScript for a while has been the concept of declaration spaces. There's a variable space and there's a type space. For example, I have a variable called foo. I cannot go ahead and a type called foo. I cannot go ahead and say, well, there's a new variable called bar, which is of type, which is the type foo. I can say it's of type foo, but it isn't like foo. The type doesn't exist over here. The variable doesn't exist over here, and you actually get a nice error that foo only refers to a type, but is being used as a value over here. Similarly, I cannot go ahead and I can create a new type to point to an existing type, but I cannot create a new type to point to a variable because the name foo is not available in the type declaration space. Now there have been features within the language for a while. For example, typeof that allow you to move items from the type declaration space into the variable declaration space and vice versa. So for example, I have an object person A and an object person B. I'm really lazy. I don't want to create a new type called person that has first name and a last name strings. This is an existing code base. So what I can actually do is just say that, okay, so all of these persons are of the type whatever is inferred for person A. So now if someone goes ahead and refactors person A to be something else, you get a nice error that, okay, this object no longer conforms to the type of that variable. You get autocomplete over here as well, and all those other awesome TypeScript thingies. You can even name these types if you wanted to. So I can actually, instead of having to define a new type, explicitly I can just say that person is something that is whatever the type you've inferred via TypeScript about person A. And now I can use this new type as a type annotation. But they really pumped up the power of these moving types around in the type declaration space and the variable declaration space a bit more. So one of them is lookup types, and I just absolutely love this. I deal with a lot of backend code and external dependencies that take data payloads that are massive like this one. So we have a submit request that takes transaction ID and a personal member which has these properties inside and stuff like that. And if I have to create this particular a variable of this type, what I'd have to normally do is, well, submit is something that is of type submit request. And well, I want to make the driver property, and now I have to write down all the driver properties within this single JavaScript statement before I can actually move on. And we as humans don't think like that. We try to break down problems into smaller problems. So if I wanted to create a submit request, what I would normally do is, well, it has a payment section. Let's create a payment section. And I want this payment variable to be of the type whatever this submit request takes. What I can do is actually create a new type called payment over here, which points to that particular subsegment, and then I have to go ahead and update this submit request to say that payment is of type payment. And I can do that. So now I have a payment over here, and I can like TypeScript will autocomplete and all those good things. But it's a bit painful for the next guy. The next guy has to, if I do it for all of these, I'll have 6, 7 new types that I have to name, and naming is one of the hardest things in programming. And the next guy has to, they'll see submit request, and then they'll see it has these members, and one of them is of personal whatever I called it at the time. And the next guy will have to go through this, and then they'll have to go through each of the type definitions for these things to figure out what's going on over here. So you don't have to do that now. There's a concept of a lookup type. So I can simply revert this new type, poorly named type, and I can just say that payment is something that is a part of the submit request payload, and look up from that the member payment. So you can use any literal string, and like TypeScript understands literals now, so it knows that this payment is a literal. From submit request, take payment out, so credit card token, autocomplete received, type checking received, all those things. Didn't have to come up with names, didn't have to confuse the next guy with why are there 20 types in this file when all you needed was just one.
Does that do nested as well? Like you've got
Yes.
previous aliases?
Yes, yes. So I can actually go, it is of type personal, previous aliases, and so the question was, can I do nested as well? So I just took payment out previously, right? But I can even go ahead and take out personal, and from that, take out previous VIOUS addresses. I would actually stop at this point normally as a code thing. So there's a typo in there. Let's figure that out. These aliases, not addresses. I love TypeScript.
So you ask like the payment, the type of the payment, shows all these.
Yes. So
So it's a type of payment.
yes. So if the question is, if I ask TypeScript about the type of payment, what will it show? Right now, I've said that it is of type submit request, and from that the personal details, and from that previous aliases. Previous aliases is this object over here, which is an array of these things. TypeScript knows that payment is, you can see the, yeah, I can have her, is just that. So it's figured out that it's just the previous aliases portion. This empty object over here does not conform to that. If I actually just go ahead and say, well, I'm going to create a variable later of this type, you can see that it has figured out that payment is something that has type, string, first name, middle name, last name, and it's an array of these things.
Just one very quick question. This is pretty interesting. Is it similar or different to like ambient module declarations? Because one of the biggest pain points using TypeScript with third-party libraries is the TypeScript definitions. Sometimes they can be ambient. So does this in any way help that problem, or technically just for internal use?
So the question is has this feature got any similarity with ambient declarations? So ambient declarations are, for example, I want to use jQuery, and I want to get the value for some selector. If I just write that in a new TypeScript file, TypeScript is going to complain. jQuery is not something that is available by default. So $ is not something that is available within this file. But I can actually go ahead and create an ambient declaration. I can say that, dear TypeScript, there is this variable lovingly called $ that I want you to be quiet about. And now TypeScript is quiet about it. It's gone ahead and said that, okay, there's a variable $ of type any. I can let you do whatever you want with it. I'm not going to complain. Now, writing these declarations is very similar to writing this type definition for a payload that I'm going to send to the backend. So that's pretty much the extent of the similarity. You can, of course, create new types. For example, payment info is submit request from that take out payment. And that is valid as well. So when you're writing type declaration, and if you feel that, oh, this type is getting used too many times, you can, within your type declarations, use this feature as well. Nothing barring that. Yes, go for it. Nope, don't go for it. All right, so that's lookup types. Key off. Well, we have type off. There's a new thing called key off, which is person keys is any of the keys of person. So I created a new type and asked it to TypeScript to give me the union of all the keys that it has for the type person. So person keys is going to be the union of the strings, literal strings, first name and last name. By itself, it doesn't sound particularly exciting, but when you combine it with generics, which is why I showed generics, and fortunately generic constraints, it becomes much more powerful. So here I have a function called prop, which takes two parameters, an object of type T and a key of type K. And I have a constraint over here that K must be something that is in the keys that are inferred for type T. So if I go ahead and call prop on an object that has foo and bar on it, what's going to happen is TypeScript is going to infer that the type T, based on this argument position, for the prop function over here, is of type foo and bar. And the type K must be something that is in the key of T. So the keys of type T are foo and bar, and this empty string or some other random string is not foo or bar, so TypeScript is going to complain about that. And it's actually probably even going to, no. All right. It's only going to allow valid keys from this object. And something like pluck, Lodash is full of it. You can actually, with this key off combining with generics, you actually get much more powerful type annotations for existing JavaScript. So that's key off. It gets much more interesting. String enums is something that has been requested for quite a while. TypeScript has that now. So I can say const direction is of type direction. So, well, north is a valid value, and if I go ahead and log it out, it's going to be the string north, though surprise is there. One of the really, really cool features is read-only. JavaScript has the concept of read-only. It has had that for a while. TypeScript understands that. It has understood that for a while. So if I have an object with a class with a getter, so const foo is a new foo that has a getter, I can get bar, but I can't assign to bar because there is no setter for bar. And TypeScript understands that, and it complains about that. There is absolutely no TypeScript-specific feature here, except that TypeScript understands it. TypeScript does have a feature called read-only, which allows you to, instead of using getters and setters which have runtime overhead, you can actually just annotate a member with type read-only, and it would have similar semantics as something that just has a getter. So it's read-only from the outside world, so you cannot assign to it, and that works fine. What's more interesting is that you can actually combine these with the feature called mapped types. So here I have a type read only, which of type T, which takes all the keys of type T, and for each member in that set, makes them read only. The value for each of these would be the same as the value that would be in type T for that key P or property P. So if I have a type foo, I can always do foo is of type foo. So I can have A, 1, 2, 3, B, something. I can assign to it. Cool, that's how type foo works. But I can actually even go ahead and now say that foo is not of type foo. It is of type read only of foo. And now TypeScript is going to go ahead and infer that it'll have all the properties foo, but each of these would automatically get marked with read only, which means that if you try to assign to it, it's going to be an error. And this read only type actually exists within the default lib.d.ts, so you don't actually have to write it yourself. If you just want to convert a type into a read only type, you can just use this type annotation and you're good to go. As you can see, it's in the lib.d.ts. What's really cool about this is when you combine it with language patterns that exist out there. So here I have a simple React file that renders out a button that shows the state's clicked count. Right now on click is empty, so nothing happens when I click it. I want to increment the clicked count in state. TypeScript understands React. It's just fascinating. It's amazing. Now a beginner developer might actually do something like, oh, I can actually just state.count++, and what they'll quickly find out is, well, that doesn't work. So they'll look at, just update it for me. React, just go for it. Shh, be quiet. And it'll work, but it's horrible. That's not what the React components assume that you're going to call setState with the new object, and it will control when it wants to render. You shouldn't be using forState unless you explicitly need to. So TypeScript actually figures that out now, because it knows that I created a React component with a member called count of type number. Within the type definitions for component, you will see that it has a property called state, which is read only of that type declaration. So of this state type generic over here, the state member within the class instance is going to be a read only of that, so you cannot actually increment that. And I've had beginner developers write something which is probably very easy to miss, where you go ahead and say count is, okay, so I understand I'm not supposed to use force update, I won't use that. But I just want count to be, well, plus of the current state count. So I'll just call setState with that. And then we'll commit it, and it will work. It will not work. I thought it would. But TypeScript has actually figured out that state plus plus cannot work because it mutates the state. So you actually have to do something like that. Cool. There are lots of other features within this release, and lots of new features coming out as well. What you can actually do to keep up to date is I recommend just updating your package.json TypeScript to the latest version. It'll find bugs in your code, and there'll most likely be bugs in your code. So just be thankful and move on. Stay happy. Any questions? That is it. Thank you all for coming.